Well, hello everybody, this is Joe Van Cleve. Hey, as promised, I'm going to do a little video about making these super simple PVC pipe pinhole cameras. Stay tuned. Okay, if you've been following the channel the last few weeks, you know that I kind of rediscovered this little 9-camera film canister pinhole camera kit that I had made a few years ago. Well, now I'm wanting to go back to this multi-camera idea, but with a larger format. I like the 2.5-inch square film format, but of course that's too big for film canisters, and so I've decided, hey, it would be kind of cool to make a slightly larger camera. And this is one of the easiest pinhole cameras that I've ever made, and I want to kind of take you through the process. It's pretty simple. Essentially, you need 1.5 inch PVC pipe, black pipe, and you need pipe caps for 1.5 inch PVC pipe that fits snugly on it. You'll need a way to cut the pipe, and you could use a hand drill for drilling a hole in the side of the canister for the pinhole to be mounted into. I use a drill press, relatively inexpensive at Harbor Freight Tools here in the US. But anyway, let's go out to the garage and let's build some of these, shall we? So when I originally was wanting to reproduce the general angle of view of the film plane of these little film canister cameras on a larger scale at the 2.5 inch size film format, I had to kind of figure out what size PVC pipe would be the right diameter. And I had a spare piece of pipe laying around, and I figured out that 1.5 inch looked like it was the right size, because if you put this 2.5 inch piece of paper in 1.5 inch PVC pipe, it looks like it's about a 180-degree wrap. So I had to go into the hardware store to find some 1.5 inch pipe and pipe caps. And at the local hardware store in my neighborhood, the shortest piece of pipe that they would sell is 5 feet long, 60-inch long piece of pipe. A little bit longer than what I needed. So how many pipe caps would I need? Well, I figured for my 2.5 inch size format that each PVC pipe section for each camera should be about 3 inches long, and I wanted to take into account the kerf of the saw blade, the amount of wastage, so I figured 3.25 inches for each pipe. You get about 18 cameras that I can make from that one pipe if I wanted 18 cameras. In reality, I probably only want about 9 of them. So 9 cameras means I would need 18 caps. Well, they only had 14 caps in stock at the store the day that I went there, so I bought all 14, and that's enough for 7 cameras. I still need to go back and get 4 more caps so I can make a total of 9 cameras. So the inexpensive way to cut PVC pipe is just to use a hacksaw and a little manual miter box, but if you happen to have a power miter saw, it's a lot easier. So I'm going to set mine up outside. Okay, I'm just going to roughly mark a piece of tape around part of the perimeter of this pipe at the 3-inch mark. So I'm just going to put some tape here and then make a mark that I can reference with my miter saw. Now, if you are going to use a power miter saw, or even if you're using a hacksaw by hand, be careful about the little shavings of plastic. Plastic shavings are like metal shavings. They're not going to soften up. So be careful, wear some eye protection. So when I was making this prototype pipe camera, I had to figure out how big of a hole to drill in the side of the pipe to account for the pinhole and the angle of view of the curved film plane. Keeping in mind the curved film plane is going to be a pretty wide angle of view, at least horizontally, and so I figured a 1/2 inch diameter hole would be adequate, and it probably is not, because if you look at some of my exposures, like for instance this one taken out in Bernalillo last week, you'll see I got some vignetting in the corners. So it looks like a 1/2 inch is a little small. I should have gone to perhaps 5/8 of an inch drill bit. Speaking of drill bits, let's talk about what you'll need. So the problem with a lot of these projects is if you want to do a really good job, you end up having to buy stuff. Now, that can be a problem if you're on a limited budget, but it also can give you an excuse to build up your tool collection, and that's what I find is cool. But what I like to do is I like to start with a 1/16 of an inch or a really small drill bit as a pilot hole. And then I use what's called a Forstner bit. This is a Forstner bit. This is the 5/8 size bit. So I'm going to go ahead and use my drill press, and we'll try drilling a 5/8 inch hole. And I've simply put a piece of masking tape on the pipe. I measured the length of it, and it is 3 inches. And I just marked the 1.5 inches, the midpoint, and that'll be where we're going to drill the pilot hole. All you need is a couple PVC pipe caps and a pinhole. When I built this initial prototype pipe camera, I just went ahead and used, for expedience sake, a piece of gaffer's tape as a shutter. So it just peels off like that, and I'm using a little folded over handle to gain access to the flap. But it may not be the most elegant way of doing things, and it won't last that long. You'll have to replace that piece of tape periodically. So you might want to think about an alternative kind of shutter. And I have an idea here. So I have some of this flexible plastic, and this is the cover to a plastic 3-ring binder notebook. Black on one side and red on another, very thin. You can cut this plastic with a paper trimmer or scissors. And I have this spare piece of plastic laying around. Now, I was thinking about cutting a piece that's wide enough to fit between the two caps and cutting a strip long enough to cover the perimeter of the pipe snug so light won't leak in. I would like to have a hole cut in the loop of plastic that I can simply turn it and expose the pinhole shutter area. So just rotate it like that. That's my idea. I'm not sure how good it's going to work, but I'm going to try it. One of the issues with that is going to be that my pinhole is going to be covered up. I won't know exactly where on the pipe the pinhole is going to be. And so what I'm thinking about doing is, if you look at the pipe caps, they have this little raised molding mark. And let's say I align the molding mark with the pinhole and glue the cap in place with PVC cement, and then just the other cap is removable for loading and unloading your paper. Then this little mark becomes a reference line for where the actual pinhole is. So this is the line that I would use to actually point the camera, and then I can rotate my shutter around to open up the shutter. One other question is going to be, do I use the black side or the red side of the plastic? Well, you probably wouldn't want to leave a PVC pipe cap thing like this laying around if you were making an extended exposure. People might think it's something else, right? And I don't know if people watch too many movies, but maybe if it's red and black, it might even ring more alarm bells, if you know what I mean. So I don't know. I was thinking maybe we can spray paint this. I don't know. I'll have to look up in my spray paint collection. Maybe I can paint this some different color before we actually put a shutter on it. Or maybe I'll just paint the caps. Maybe I'll paint it in pink with Hello Kitty decals or whatever. Here's a piece. It's just under 1 inch, like 15/16. It should be plenty wide enough and give me a little extra leeway. Now, to tape it in there, with the prototype camera, I used inch-wide gaffer's tape. This is already almost 1 inch, so I'm going to go to my other roll of gaffer's tape, which is 2 inches wide. So if you're doing this, you're going to have to think about, if you certainly need something like gaffer's tape. I would not advise standard duct tape. It just doesn't hold as well, as securely, as long, and it's not guaranteed to be light tight. Black gaffer's tape tape, the actual cloth tape, is really good for pinhole camera building. So maybe invest in a 2-inch wide roll, and that's all you need. So anyway, I'm going to make a pinhole in a piece of this, and then I'm going to install it into the pipe. I've showed you before the general way that I make pinholes, making a dimple or in the brass with a needle and then sanding it down to sand off the tip of the dimple, starting a hole, working it out with the needle round, getting it to the right size. But I want to try to see if I can show you close up how I measure the size of the pinhole. So in order to do that, I'm going to have to get it really close up. 1, 2, 3, and 4. To the start of the next line. That's 1/4 of a millimeter, pretty close. So it's just an iterative process. Start with too small of a hole, try to enlarge it as you go until you get the right size. And you also want it to be very round, no burrs. So in actual practice, I'm not using this bellows rig on the camera to measure my pinholes when I'm making them myself. This was done really for the benefit of you guys. What I actually use is just a little magnifying loupe of some kind. I have several of these, and just hold it up to the millimeter scale like that and measure it, and it's pretty easy to see. So when you're measuring the size of your pinholes with this method of optically measuring how many diameters fit in a millimeter, if you come up with a non-whole number of diameters, like let's say 4.5 diameters fits in a millimeter, what you want to do is simply take the inverse of that. 1 divided by 4.5, and you have a 0.22 millimeter diameter pinhole. Or in the case of, let's say, 5.5 diameters, right, you would have a 0.18 millimeter pinhole. So that's the way to do that. And then I'm going to want to cut a little hole in the piece of tape. The way I do it is I fold the tape over on itself so the adhesive side is out. Fold it in half like that. Make a little ridge, a fold, and now I'm going to make a little snip at a 45-degree angle, and then at 90 degrees to that I'm going to make another little snip, and you'll be left with a little diamond-shaped hole. So my piece of brass has a natural curl like that, and I want to have that curl follow the interior shape of the pipe. So this convex side is going to be toward the outside, and therefore the concave side is on the inside. So I want to put the tape on the inside here on the concave side. So I'm going to lay the piece of brass down, and I'm going to just superimpose the hole, the diamond-shaped hole of my tape over, and line it up and get it stuck on there. Okay, I'm going to go line up this tape with the pinhole and get it set so the pinhole is in the middle of the diamond, like that. So I have the tape firmly pressed down against the inside wall of the pipe, and there is the pinhole centered in the opening. Looks less like an improvised device, hopefully. I don't know. Anyways, you guys can use your imagination for however you want to decorate yours, if that's your intention. Okay, so for the shutter, I have an opening of about 1.75 inches between the caps. So I want to slice this piece of black down to 1.75 inches. Okay, I have it wrapped around here so it feels snug, and I'm marking with a pencil. That seems to be the only thing that marks really good on this matte plastic. I guess I'm going to make black on the outside. Should I do red on the outside? I haven't really decided, actually. Red and blue, does that look less like a suspicious device, or black and blue? I don't know, red just screams too much attention. I think I'm going to do black. So I have my shutter with a 3/4 inch rectangular hole. The tape is already applied and on one end, and now I have to get it wrapped around the other side so that it's snug enough to provide a light tight seal and not turn too easy, but not so tight that it doesn't turn at all. I'm not really happy with the way the stiffness of the plastic is. So let's see how this works. So I'm just going to be probably turning it off to the side like that. I'll turn it to open it and continue the same direction to close it so that the exposure is going to be more even side to side. And then I guess the little ridge up here in the back where the two ends meet, maybe I can use it as kind of a handle to kind of operate it a little bit. And so it slides like that to open, and then slide it again like that to close it. Looks like it might work okay. So we're actually ready for first light. And you know, we got some daylight outside, so I might load up a sheet of Harmon paper in this and see if it's any good. Okay, one other little addition I made to the camera is I hot glued a round magnet to the bottom cap. So hopefully I can mount the camera to the little magnetic or metal mounting plate that goes on the tripod. Alright, I've pre-flashed a 2.5 inch square piece of Harmon paper. I'm going to go try to find a composition around the yard and expose it. Okay, let's start the exposure. There we go. Okay, so last week when I was doing some test shots with the prototype camera, I was rating the Harmon paper at ISO 8. It was a little overexposed, so I've metered it at ISO 10 instead for this one. And I pre-flashed the paper, my normal amount that I've pre-flashed in the past, and hopefully I didn't overexpose the paper, we'll see. But the first exposure was 22 seconds, the other one was 15 seconds, kind of partly cloudy, variable light, a lot of shadows and stuff. I'm not really sure how the metering turned out, but I'm going to go ahead and set up and process these two in the one tank, and we'll see what we get. Okay, developed it. Let's see what we get here. Alright, so the first one was outdoors, looking at the kind of the tree in the backyard and stuff like that. Let's see if I can get a shot of this. Yeah, I kind of like that. The shadows are a little light. That's kind of cool. Oh yeah. There's the crow against the back wall. This was 15 seconds in bright sun. Some nice dark shadows and light tones on the wall. Kind of like it. Well, there's obviously some differences in exposure between these two prints. Let me try to explain it. So they were both developed in the same developing tank at the same time. So there's no real differences in chemistry or developing time. The metering of the scene was pretty much the same. And so the only difference was the first image, I pre-flashed it in my dark room with the pre-flashing light source I've been using, and I was using my newer used timer at the same time, 3.5 seconds, that I've been doing all along for Harmon paper. But on a hunch, this afternoon after these results came out, I took a timer out and timed that 3.5 seconds, and it was really more like 5 seconds, a little bit over 5 seconds. So that timer wasn't really accurate, and it may have some variation in temperature when it's cold out there. Maybe it runs slower. So I think the pre-flash time was simply too long. It was getting too much pre-flashing. Now, the second image, why is it so dark, is because I didn't actually pre-flash it. I forgot to. So I decided that I needed to make a third image this evening, and I set up another still life here on the table. This was 2 stops overexposed from the metered reading to compensate for the color of the light. These are regular household LED bulbs. 25 minutes exposure. This is the same exposure I gave the other still life from last week, but it looks pretty good. I really like it. The light was all concentrated on the closet door behind the figures there. So we have a pumpkin, and we have a duck, and we have the running man or jumping man. So I think this is a pretty good lesson about exposing Harman direct positive paper and pinhole cameras is you have to be really consistent with your exposures and with especially your pre-flashing. It has a lot to do with how good the shadows look, and you can see readily the drastic difference in shadow detail between the two pictures that I showed you earlier. Make sure you pre-flash, make sure you're consistent with it, but I really do like this still life result, and the nice thing about these still lifes is I can certainly shoot these anytime I want, day or night. I'll leave it to you Freudians to decipher the meaning of this still life, but I'll just quote Mae West as having said, "Sometimes a banana is just a banana." This is Joe Van Cleve, and you guys have yourselves a great day.